This is a molecule we named in a previous video where we named it trans 1,1-ethylbutyl 4-isopropyl cycloheptane. And someone commented, where is the chirality? And they're right, there is chirality here. And we didn't address that, so we're going to address that now. So remember, chirality is when you have four non-equivalent substituents on a carbon. We have to remember here that we have implicit hydrogens drawn. I don't want that in red. H, that one's coming out at us. That's a terrible H. Then we're going to have one that's coming away from us on it over here. So now I'll switch to red. What is the absolute conformation of these chiral centers? And there's two, one right here and one right here. So when we label our substituents, you go importance. So we go carbon, this would be number one because it's a carbon linked to two other carbons. And we have CH2, 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 CH2. And now we have a CH2 and CH because now this is linked to the carbons. So it goes 2 and 3. And what I like to do is you either have 1 or 4 on the dash bond. Preferably 1's on the wedge bond. You have 4 on the dash. That's always the best. But what you can do if it's the other way around like this, you just see which way it goes, and it goes clockwise like this. But then remember, because your main one is on the dash, you reverse it. So really it's like this. So this is an S configuration. Now if we come over to the second one over here, we can do the same thing. We have 1, 2, 3, and 4. Like I said, this way we have our number 4 on the dash bond there. So this is the best way to do it. We can just go right up and see that it comes counterclockwise clockwise like this, and there's also S. Now, what if we wanted to flip it? Here, I'm going to erase this here. What if we wanted to flip it? Would that affect our stereochemistry, our chirality? Well, no, it won't. Let's see, what would that look like if we flipped that? Oh, where I can't grab this. Why can't I grab this? Here, this is our. Oh, what happened there? Our flipped molecule. And if we go, remember we have implicit hydrogens here, H, and this H. We number them the same way. We have 1, 2, 3, and 4. Maybe are counterclockwise, so it's S. And we have 1, 2, 3, and 4 clockwise. But we have to reverse it. So really it's counterclockwise, so we're S again. So it's still the same configuration. We just flipped it, but remember, it's just the same molecule, just flipped, just looks a little different. Now, what if we just made this on a wedge and this on a dash? What would that look like? So we have this over here. All right, grab this. And so now this is where things start to change a little bit. So, well, this is also trans 1,1-ethylbutyl 4-isopropyl cycloheptane. It's not the same as this one right here. This is here. We have 1, 2, 3, and then 4. That's terrible. It's clockwise rotation, so it's R. And here we have our H. We have 1, 2, 3, and 4. We have counterclockwise, but we have to reverse this, so really it's clockwise. So this is R as well. So this one is RR. So, and this one is SS. So they're enantiomers of each other. So what we need to do is add this to the front of our name. So this would be, this would be FS. Sometimes you'll see it in parentheses. It'd be like that. this. Because while this is trans 1,1-ethyl 4-isopropyl cycloheptane, so is this. And the one we have here is explicitly drawn as the S configuration. So thanks again for the catch in the comments. And remember, always watch stereochemistry.